I'm moving you from the mountains down into the valleys, and we will be looking at rivers and looking at the question of what are ecologically functioning flows in altered rivers. All of us love beautiful, diverse floodplain rivers, and also the species and biodiversity in total love floodplains. Studies have showed that 80% of the species in Switzerland actually occur on 0.5% of the surface area of the entire country. However, in the last 150 years or more, it has shown that actually in Europe we lost 90% of all pristine floodplain areas. In Austria this was 85%, and the remaining 60 are protected, whereby in the Alpine area it generates 92%. So what is happening, aside from land reclamation and wetland drainage, we have the problem of hydropower, and especially diversion hydropower, where the water is taken through underground tunnel led to the powerhouse, and the remaining stretch, the residual flow stretch or inventive flow stretch, is significantly changed in its flow regime, which causes a series of ecological consequences. The riverbeds might be dried up, the wetted area might be lost, flow velocity, depth reduced, sediment colmatation might happen, vegetation might encroach into the river, or algae blooms and temperature increases might occur. We looked at how many of these rivers in Austria are actually within potential floodplain areas, and we found that it was 52 of all rivers, indicating a high chance of restoration potential. But however, 69% of all these rivers still lack an environmental flow. So if you look at a floodplain area, then actually the river flow can be considered as the orchestrator or conductor, like in an orchestra where the multiple instruments play together to have a beautiful sound, and this is how a floodplain system works. So we did a study that was published last year, and we wanted to analyze the interplay between abiotic and biotic interactions in functioning systems, show how they are altered in altered rivers, and propose flow restoration measures and identify key flow regime elements. This was a conceptual graphic which we ended up with. In gray, the natural regime, in blue, the proposed regime, and the altered one would be somewhere down here. So in general, the question is, how far can we deviate from the natural regime while retaining key principles? And we identified some key flow areas. So firstly, there's a need to increase the minimum flows that are released downstream of the hydropower plants, but indicated by here in these low flow areas. The increase of minimum flows, this should be actually a flow restored stretch in Switzerland. As you can see, the increase in minimum flows should actually increase the minimum habitat available for different species. For example, provide sufficient water depth for adult fish, and these events should not have an unnatural prolongation. Furthermore, flow variation in this category is very important to inhibit like fine sediment accumulation, like you see on this picture. And different aspects. So then next to that, the other category is the increase also in mean flows and its variability. Mean flows occur approximately in natural systems 25% of the time, and they are key key quality for habitat quality, quantity, and among others, they determine the migration and the longitudinal connectivity between habitats. So we have different fish species, for example, that have to migrate longer distances, and they have to be able to reach the certain habitats for different life species. At the same time, also, if we look at vegetation, the mean flows are important for groundwater levels. Another flow group are high flow and flood events, and also the downcrease after the annual flood event. And these should be synchronized with natural occurring high flow periods and trigger migration, spawning, and others. flood events that occur on a regular basis during the year are important to maintain. Heterogeneity of the sediments, they flush out small sediments, prevent siltation, flush out periphyton, trigger spawning migrations, or other functions. And the high flows, the last one, they occur every couple of years, and they maintain, actually they're called the channel maintenance or overbank flows. They maintain these habitats, creating erosion, sedimentation processes, and also facilitate a variety of other ecological functions. So in total, this is the entire graph, how it looks like. So basically, this is the natural regime, and in rivers that are already impacted, we propose this, what we call the functional floodplain flow regime, in blue, with all its elements and how they interact with biota. But last but not least, aside from the biota, functioning floodplain rivers are also important for us, for fishing, for clean drinking water, recreation, natural flood protection, just outdoor play and enjoyment. So I think it's important that we preserve our last floodplain rivers and restore those that have already been impacted. So thank you very much.